Well, I was going to say about the dust collection, because originally for years there was no dust collection. You guys had hands-on, you could block off the bottom and put some ports down there, but that was, only so good. And then you take a hole saw and you cut a hole, and you attach an elbow, a flange and an elbow was the first Shopsmith retrofit kit for that. And then the fact that over the years, then you adapted I guess it would be, are those plastic injection molded? Have those? Yeah. So then you had to invest in new tooling to do those things that you've done.
Right. And that'll even work on the first generation bandsaw with the cast aluminum cover.
Wow.
Get out the hole saw.
Yeah.
and screw it tight. I pride myself on being able to, everything that I design can go back to the early 1950s models, the first generation Mark V, the old Greenie Gilmers.
Yeah.
And be able to update to today's technology. Doesn't matter whether it's the bandsaw or the headstock or any of the SPTs.
Very cool.
We can upgrade it. Now there are things that we don't make anymore, like the old jigsaw, that we even have difficulty servicing these days because tooling has been lost, discontinued. The machine is made so well that we only sell 6 or 8 service parts a year, and minimum order quantities are in the hundreds. And we either pay a CNC manufacturer $100 a piece for this part, or we don't sell it.
Yeah.
We're kind of stuck between a rock and a hard place, but the alternative is buy scroll saw.
Yeah.
So,
which is a big improvement anyway.
Yeah. So it's when we discontinue a product, we usually do it when we've got a good alternative to it.
Yeah. I've been playing around some recent videos on the conical sander, and I thought, okay, before I show the conical sander, let me show how you would use set your Mark V up to use a flat disc for edge sanding. And of course, the downside is you're getting cross grain sanding, but you can offset the fence, and now you have safe sanding. But on the 520 fence, we don't have a way to offset the fence. But by the time the 520 fence was on the market, we had a conical sander, right? So there's your solution. And then with that ushered in the ability to sharpen joiner planer knives, because we have a sharpening jig. Did you create that, or were you involved in the creation of that at all?
Yes and no.
Yeah.
Hans Goldschmidt created it.
But the conical disc? No,
well, in effect, yes. Not Hans Goldschmidt. De Cristoforo created the sharpening jig. He showed that in Power Tool Woodworking.
Okay.
And I incorporated that with the conical sanding disc to make it work the way it does today. But the early aluminum cast discs had a beveled edge to them, so they worked much better as a edge sander than the flat steel disc did. So it was a combination of the old aluminum disc technology, the improving on the flat disc, the Hans Goldschmidt joiner sharpening jig, and
De Cristoforo.
De Cristoforo joiner sharpening jig, and the conical sanding disc that I saw at Gershner's, because they didn't, the edge treatment on the toolboxes, they didn't run that through the joiner planer. They just glued it on and then ran the whole assembly or the whole board past a conical sanding disc on a table saw to sand that front edge. And I always looked at that and said, where are the swirl marks? There aren't any swirl marks because that conical sanding disc is tilted, and so you've got straight line sanding grip at the point of contact. It was really a multi-step process of learning over several years that put all that together.
Yeah, very cool.
So it's a lot of things are an evolution and increase in knowledge as I live and breathe and learn. So it's 42 years with a company. You learn the machine inside and out. I started learning it from using it, and then the owner's manuals, and now into engineering, learning from the engineers that were here before me.
Yeah.
Taking their knowledge, applying it to today. And when I was given the job of fitting everything in a Power Pro, all the electronics in the Power Pro, the first generation of the Power Pro headstock had this big box sticking out the back of it. Bob says, no, that's unacceptable. We've got to find a way of getting that inside. And sketches that I made, ideas, Bob put back to the people at Strytech Technitool, and they came up with an enclosure. I'd taken the electronics cover off of it and stuffed it inside, and it still was too big, and they re-engineered the board to fit inside the housing that we've got now inside the headstock. Had to move some components around, re-engineer that big power supply board. But they got that done, and it fit inside the headstock, and the motor fit underneath, and had to fit in the original motor pan, and belt cover had to go over the outside. It's the only thing that looks new is the control panel, and then that allowed us to upgrade all the way back to the old green sandcast headstocks, the 1953-54 era.
With electronic variable speed.
Right.
Incredible.
So
hold on. So you mentioned the name Bob. So Bob, who's this Bob who can say he's not happy with a box on the back of the headstock?
Nobody more than the president.
Oh, that Bob.
John Folker's son, Bob Folker.
Okay, and John Folker was the gentleman that back in the 70s who bought the company that had really gone dormant in the late 60s. So the Shopsmith line had passed through a couple corporations' hands and then kind of stopped. It was down in Mississippi, I think it was. And then John Folker discovered it, brought it back to life, brought it to Ohio. And his son is now the president of the company. The company actually, again, changed just a few years back, right? It went from Shopsmith Incorporated to, is it RLF Shop? Doing business as Shopsmith, yeah.
It's an LLC now.
So Bob Folker saw that and said, not good enough, work this out, and he did. That is such a neat design. I retrofitted that Sandcast 54, 55 Mark V with that, and it was incredible to think that we're putting this brand new heart. It's like the heart of I don't know, the Terminator going inside of this ancient headstock and breathing a whole new life and more power and the ability to run on either 110 or 220 and all the great things that did. Very cool.
But one of the things that I found, I had collected old headstock castings from customer repairs for years, discovery, just to keep them in archives because there were changes along the lines. And that measuring those old headstock castings proved to me that there was only about 12 thousandths difference from side to side inside the casting, from even the earliest sand casting to what we make today. The engineers held the inside dimensions sacred. And when you go from a sand casting to a die casting, the wall thicknesses is generally cut in half, if not by a third or by 2/3. And that dimensional change was all done on the outside of the headstock, and the inside profile shape of the headstock was left the same. So I had a much easier job designing motor mounts, mounting for the power supply. The distance from belts had not changed on the idler shaft to the upper auxiliary shaft. Over 50 years of evolution.
Yeah.
None of these sacred dimensions have changed. Of course, way tube dimension has always been the same since they went from the 10 yard to the,
yeah.
so that has made things easier for this evolution to the new millennium, really, to the electronics, and being able to put those electronics in the even the oldest headstocks. Yeah, our table systems are able to upgrade the same way. Because the way tube dimensions have not changed, the distance between them, the new carriage, new table system goes right on that very old machine. Just slide one off, slide the next one on. So it's that's what's kept us in business through thick and thin.
Yeah.
Probably the biggest hit ever to the company was the Taiwanese copies of the Mark V being sold at half or even 2/3 less than what we were selling them for. And people would run to the cheap price. They would pay $500-600 for them instead of $1,200-1,500 that we were charging.
Yeah.
And get them home. And then there were some good things about those early Taiwanese copies that taught Shopsmith some valuable hard lessons. They ran smoother than ours did, quieter. They came up with the two bearing quill before we did. They forced us to re-engineer the quill, rebalance the or look at the balancing of the sheaves, improve them, because we now had competition that we didn't have before.
Set screws on the top of the tie bar and the base casting instead of having to fish your wrench up from the bottom.
Yeah, that's.
I saw that for the first time. You guys had a total shop that was in the R&D lab when it was kind of pretty new, and I saw it's like, that's so smart. I mean, it's not as pretty, but it was smart.
It was easier to get to, and it made upgrades easier.
Yeah.
And changing tubes easier, and any reason, just rotating the tubes so that the headstock and carriage slide better.
Yeah.
That's where it was used the most.
So
that's
great.
Little changes like that throughout the years have improved the machine.
So I think in a similar vein, I noticed that you guys have like the top dozen, 20 items that might need to be replaced. You got the impeller for the dust collector, and you got the V-belts and the this and the that. Why do those exist? Why are tools made that have these things that someone's going to have to replace? Why not just beef all those up and have them never fail? Reason?
Well, there always has to be a weak link in power chain that is easily corrected to save the rest of the components in the drivetrain. The first good example of that is a shear pin on the propeller of an outboard motor. You hit a stick, you hit the bottom, that shear pin that costs pennies breaks instead of breaking the propeller that cost hundreds of dollars.
Right.
And so we've incorporated things like belts or wear items, and we've got an expected life on all these belts, and
Yeah.
we've got to meet or exceed that expected life. But that belt also has to slip under extreme circumstances to save the rest of the drive system. And that slipping is what causes the wear. But it also saves the sheaves and the shafts and the keys and the things that are more difficult, more expensive to repair.
Yeah.
So there's always a weak link. The power coupler is the weak link between the headstock and the SPTs. It used to be advertised as unbreakable, and I don't know whether it was at the time.
Made of DuPont Zytel.
Yeah. You used to read those ads too.
Yes.
They were, I don't think they were ever intended to be unbreakable. If you get a catch on a joiner and pick a knot out of a piece of pine and it jams in the between the cutter head and the tables, we don't want it to break a knife or the cutter head or ruin the bearings. We want it to break the coupling in between the cutter head and the headstock, or at least we want the belts to slip. So so the parts of the joiner don't break, so the parts of the headstock don't break.
Right.
That immediate shock of going from 5,000 RPM on the joiner to 0 in a portion of rotation is a severe shock to the system.
Yeah.
When a weak link can break and save the system, it's worth breaking that coupler.
Yeah. And you guys test this. You've got in your lab the ability to test, and you can isolate individual components to test that particular link in the chain, right?
Yeah, right. We can. I had a pendulum test that could jam a piece of wood into whatever cutter we were testing at the time to check the to check for the weak link or the durability of the cutter or whatever. I used that for anti-kickback testing as well as coupler testing. When we developed the cams on the 510, 520 Mark 7 upper guard, we had to first figure out what a kickback was, what caused it. I mean, you got to start at the beginning to test at the end. So we had to use impact testing. We had to create kickbacks. In order to create a kickback, you got to understand a kickback. You got to know what causes it, so that you can't just hit a board with a hammer. And because there's no way of qualifying that to real life.
Right.
So I created kickbacks by extending the quill into a board. It slid along the fence and hit what's called an accelerometer, which measured the impact force. I could turn that into foot-pounds of force and create a pendulum that swung at that same rate, or increase that rate for 20, 30, 50% safety factor. So when I was doing the kickback testing on those rotating cams that are in the upper guard, I used a 50% increase in the load. The cam still turned. It jammed into the pivot pins catch in the serrations across the top of the slot in the upper guard. Yeah. It pushes the cam up into that serration. The cam rotates and it pinches the wood between the table and that cam.
Right.
And
So you were able to reproduce the action, the movement of the wood without actually having to cause a kickback with the cutter head.
right.
That's really interesting. Why not?
By swinging a pendulum into the back end of the board.
Yeah.
That kickback mechanism is so efficient that it works without digging into the wood. It'll prevent a kickback on a Formica covered piece of countertop.
Man.
Where other anti-kickback systems that require sharp teeth to dig into the wood won't.
Yeah. Okay. So that's first off, it has to be used, right? You have to have the lower saw guard on and installed properly and aligned properly. And then you have to have the upper saw guard on. It drives me batty when I hear people say, well, I don't use the guards. And on some table saws, the guards were there to protect the company more than they were to protect the user. But man, that 510/520 guard is fantastic. And the dust collection works. And why folks wouldn't use that is beyond me.
Yeah, and it doesn't take a lot of time to set up. You can keep the saw blade and the lower saw guard, and they go on together. The adjustment is set by a stop screw. You do that once, then you slide the upper guard down into the clamp through the table insert. If you hold the upper guard in the open position with your hand on top of the riving knife, another new feature.
A real riving knife. Yeah.
A real riving knife. It slides right down in the clamp. You reach under the table, quarter turn, that clamp's tight, and it's installed and aligned all at the same time.
Yeah.
Then you've got dust collection below. It's not 100%, but it's good 80-90%. I've taped mine up to block some of the holes, because the slots where the lower guard slides for opening up for datoing or for I guess that's the main reason.
Well, it actually performs a little better with a dust collector if you open it up, and it works better with a vacuum if you close it. At least that's been my experience. And so I'll install it partially closed, lower the table over it, and then I'll open it up for the dust collector.
Right. And that's because of the high volume of air that the dust collector moves versus the high pressure of a shop vac.
Yeah.
High pressure, low volume.
Yeah.
So it works with either one.
Yeah. So take us back, talking about having components that would be the weak link, but also be easy to repair. I remember the earliest Mark V's used to have a fiber clutch built into them with a Gilmer belt, a cogged belt. And this fiber clutch was there. It was intended to, again, be the weak link in case something would stop your saw blade. It would disengage, but it would destroy this little, again, I don't know how to better describe it. It was like a little gear that was made of a material that was designed to be destroyed if need be.
Yeah, it wouldn't need to change either.
Yeah, and it was a 3/4 horse motor. And when they decided to upgrade to the 1/8 horse motor, that was like, when was that, 62-ish, something like that?
Yeah.
With the like an anniversary model or something, I believe it was. But it was the gold version, the Goldie, was when they introduced the heavier motor. They took that clutch out because they knew that not only was that just going to be guaranteed to fail with that heavier motor, but they changed to that poly V drive that was designed to slip. So again, one of those things, if you look at two machines, you look at a Greenie and a Goldie, and it's like, well, they changed the paint.
Well, even you
so
look
much
at
more.
There's some Goldies that have the Gilmer drive in them.
Wow.
So that was a transition machine. That was a 10-year anniversary. That was I don't remember whether they started it before the 10th year or just on the 10th year, but it was 63 to 65.
Yeah.
Basically.
Yeah. That's like the 50-year model. I noticed the 50-year model lasted as long as your castings for the cover. That's
Yeah, the
okay.
50th anniversary model.
50th anniversary, yeah.
Yeah, we had to buy a certain number of castings, so we use them up
Yep.
till they're gone. Then we went back to the Shopsmith logo back there.
Yeah.
That's
Hey, Jim, I found an old article from Dayton Daily News. Right.
wow.
So it's got Keith Kohler standing there on the assembly line looking at the Mark V's before they go into the box. Right. How much has this process changed since that picture was taken?
That's actually mid 80s.
Yeah. Yeah.
Judging by the carriage, that's a 510 carriage.
Yes.
Probably at the time that was taking, the assembly line ran half the length of the building.
Yes.
At that time, we were in 140,000 square foot area of this building. We're now in 23,000 square feet. So we've condensed things quite a bit. We had at that time probably 100 people doing machining and assembly work in this building. We were making 40 machines a week in that area. Now we're making an average of about 5 machines a week.
Hmm.
So production has changed significantly. We've got a lot fewer people in production. The skate track that those are all sitting on will hold 4 machines now instead of 10 or 12 that it used to.
Right.
So we've got 3 guys that basically take the machine from raw parts to finished goods and out the door, where there were probably 15 people doing that same job in the mid 80s. So things have changed significantly. The tooling's the same, the way we do it's the same, the way we check it. Every machine goes out of line. So the customers,
Say it again. Every machine goes what?
every machine leaves the building fully aligned.
Ah, okay.
We have assembly fixtures that align the table as we put it together. And then it's checked during final assembly, and alignment of the slot to the blade has to be within 10 thousandths. So, and we've found through my testing that 10 thousandths alignment is sufficient to prevent kickbacks and burning. So we know that's 10 thousandths and 10 inches. We've got a square steel plate that's 10 inches square that we measure that 10 thousandths on. So it's a thousandth of an inch per inch. So it's not 10 thousandths in the blade contact area cutting through a 3/4 inch thick piece of pine. It's 10 thousandths and 10 inches.
Yeah.
We use that same standard of 10 thousandths along the entire length of the rip fence when we align it. So that's almost 3 times the accuracy, because the rip fence is 20. Well, it's 24 inches long, 24 and a half, something like that, and so it's almost 3 times. So these things are checked during assembly so that the customer, when they rip the box off of their machine, put the legs on it, they can turn it right side up, plug it in, make sawdust.
Yeah.
We tell them to check these alignment things just to make sure it's not something that happened during shipping. But we don't, unless there is shipping damage, the customer shouldn't have to align them because we do it all at the factory through jigs and fixtures.
I used to be real gingerly with my machine. Whenever I would lower it from the casters, I'd kind of lift as I stepped on the pedal, just so it didn't drop to the ground. Because I thought, if I jarred it too much, it would go out of alignment. I had it roll over in a U-Haul truck and a planer land on top of it. And I was on my way to do a demonstration somewhere. And I checked it when I got to the place. It didn't move an iota. It's like suddenly I realized this thing is far more robust than even I was giving it credit for. So that's it would take quite a bit to knock it out of alignment. That's great that you guys do that, because I remember originally we would put it together in the factory and then the customer would do that alignment.
And that was the first thing I did when I joined Hands On, was unbox the machine, go through all the steps of alignment, and you got to do them in proper order. You can't just say, oh, I know what I'm doing here, and do this and do that. And if you don't do it in the proper steps, by the time you get down the road,
yeah,
you're changing something that you did previously.
Right.
And then suddenly it's out of alignment. So
yep.
The steps and the procedures are important.
Yeah.
So it's, that machine taken care of, used correctly, you can do everything from kids' toys to grandfather clock, Queen Anne furniture, Hope chest, whatever you want to. It's capable. It's as capable as you are. It's more capable than I am.